In this video, we'll decide whether or not the series appearing here, starting at n equal to 0 to infinity, looking at an exponential in the numerator, 3 to the n, and dividing by a factorial, 3 times n, and then the factorial of that number. We're going to decide whether or not this series is converging or diverging. One approach, and a good approach here because of the appearance of factorials, is to attempt to use the ratio test. To do so, I first should identify what the terms of the series are. I'm going to call them an, and they're of this form, 3 to the n over 3n factorial. The important thing before we can even apply the ratio test is to observe that these terms are positive, and these expressions here are in fact greater than 0 for all n greater than or equal to 0. So all the terms of my series are positive. Therefore, the ratio test applies. We should look at the next term in the series. So I'm going to take n plus 1 in every place I see n here. So I'll have 3 to the n plus 1. And do it carefully here. I have to take 3 times n plus 1 and then its factorial. And the order of operations here is very delicate. First I triple the n plus 1 and then take its factorial. So it's equivalent to 3 times n plus 3 and the factorial of that number. The ratio test says look at the ratio of consecutive terms. So I'm going to take an plus 1 over an. So here's the nth plus 1 term, and I'm going to place it there. And instead of dividing by this expression here, I'm going to multiply by its reciprocal, which is the factorial in the numerator now. Let's put the like factors over each other. So I'm going to put the exponential factors on top of each other, 3 to the n plus 1 over 3n. And then we'll put the factorials on top of each other. The reason I do that is we can see some canceling. For instance, in this first factor here, the only thing left will be a factor of 3. And then in the factorial, we should expect a lot of canceling to occur as well. So let's just analyze what we have. This is the smaller one, 3n factorial. Underneath, I've got 3n plus 3 factorial. So if I'm going to calculate that, the first thing I would have to do is take 3n plus 3. Then multiply it by the number that comes before it, that's 3n plus 2. Multiply that by 3n plus 1. And then I would multiply everything that's still to come, and that is 3n factorial still, because there's a lot of factors that still need to be accounted for. The bottom line here is I'm taking off the first few factors and making what's left behind be the expression that I see in the numerator. So these two factors, in fact the factorials, will completely cancel out. I'll be left with the 3 here in the numerator, and in the denominator I'll be left with those 3 factors that remain. As n becomes large, the denominator has bigger degree than the numerator, so this expression will approach, and I'm using an arrow here for approaches, 0. Because this number, which represents the limit as n goes to infinity of the consecutive terms, and because we're getting 0, which is less than 1, this tells me that by the ratio test, my series actually must converge.